All right, so let's take a look at how the periodic table relates to these quantum numbers. And so what's crazy is they made the periodic table before we knew all of these quantum numbers and quantum mechanical science. So they had this periodic table that was just based on similarities of molecules or elements, right? We said, oh, these are all just so similar, so we'll just put them all in the same column. But we didn't know why. And so what quantum mechanics did is explains the why behind everything. And it's pretty crazy how it all fits perfectly like a glove. So the periodic table is going to help us understand these quantum numbers. So the first thing is that the row are values of n. So the first row is n equals 1, right? So this right here is n equals 1. The second row is n equals 2. The third row is n equals 3. And then the fourth row is n equals 4, and so on and so forth. Up to n equals 7. And then our columns are equal to our L's. So remember that we have 2 electrons per orbital. So over here we have L is equal to 0, and that's going to take up 2 rows because there's 1 s orbital that can fit 2 electrons, right? So we call this our s block, and it represents electrons in the s orbitals. It also includes helium, right? So you think about helium as kind of being over there, just one of the quirks of the periodic table. And then over here, we have what we call the p block. This is where L is equal to 1. So we have our p orbitals. And if you think about it, we have 3 p orbitals that can each fit 2 electrons each for a total of 6. And if you think about it, 1, 2, 3, 4, 5, 6. So absolutely crazy how this periodic table just fits quantum mechanics so well and vice versa, even though they were discovered relatively independently. And then in the middle here, we have our D block. Right, so this is L is equal to 2, and we get the D designation. Remember that we have 10, or we have 5 d orbitals that can each fit 2 electrons for a total of 10. And if you count it, there's 10 elements there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One other weird thing about the D block is that the n is a little bit different. Everything in the D block is n minus 1. So while this row is called n equals 4 row, when we come to the D block, it's actually n equals 3. And same thing, instead of being n equals 5, it's n equals 4. Instead of being n equals 6, it's n equals 5. And instead of n equaling 7, it's n equals 6, just one of the oddities. But overall, using the periodic table, quantum numbers are a cakewalk.